What's up, everybody? It's Travis here from Travis.media. Today, we're going to be building a really fun smart contract in Solidity. Now, Solidity is a statically typed programming language designed for creating smart contracts on the Ethereum Virtual Machine. If you're interested at all in creating smart contracts, you want to start with Solidity. And we're not only going to be covering the syntax like data types, functions, loops, modifiers, events. While we're doing that, we're going to be building this smart contract and getting hands-on practice. There's a lot of tutorials out there that just go through the different data types. This is a function, this is a loop, and you just go through all that and then the video's over and you're like, I didn't build anything, I just learned a bunch of knowledge. Well, this video is going to be really practical. Now, let me tell you about this smart contract. So imagine you're a grandparent and you have like 3 grandkids. And you got lots of Ethereum you'd like to pass down to them over the years. Let's say they're real little, and as they grow up, you want to be depositing crypto into their savings funds. So you decide to create a smart contract where you can add each kid, and you can deposit money for each kid whenever you want. So there's Bob, there's James, there's Kate. Over the years, you're going to give them Ethereum until a certain time. So let's say you want to do this until they're 18, or maybe until they're 21. So you're going to set this condition that says, hey, they can't withdraw this before that time. So the kid, when they grow up and they go to check, hey, can I get this money? It's going to say, no, you can't withdraw before a certain time. But when they turn 18 or whatever that time is, they can go in, click withdraw, and it's going to send that amount to their wallet. So grandparents going to be building up these savings funds for the kids, and then at the allotted time, that kid can withdraw it. Now, I think that's a really fun smart contract. You might think it's really simple, but stick with me because there's a lot of little things we got to do to make that happen. Now, there's one more thing I want to mention. You should have some programming knowledge before you do this. Like, this is not a, let me teach you Solidity as your very first programming language. This is, I know basic concepts like loops and variables and things, but now I want to learn how to create smart contracts with Solidity. So if you know all of that stuff, it's easy to switch over to another language. You just need to know the syntax for that language. So we're going to learn that today while getting hands-on in this stuff. So I hope you enjoy and have fun. The first thing we want to do is open up a code editor. With Solidity, most people use the Remix IDE. So if you go to a browser and type in remix.ethereum.org, it'll take you to the Remix code editor. Now, you can download this as a desktop app, but it doesn't have all the features and it just doesn't run right for me. So I would recommend using the browser. Now, why not use VS Code? I'm a VS Code for everything guy, but when it comes to Solidity, Remix just has everything you need. And you'll see that in just a minute. It makes Solidity development much more easier. So I would recommend using Remix over VS Code. Again, you'll see why as we move forward with this project. So once this opens up, go to your default workspace, go to the contracts folder, right click and create a new file called cryptokids.sol. That's what we're going to call this, CryptoKids. Zoom in a little bit. Now, what makes Remix so powerful is, first of all, you have your, file explorer in your code editor, of course. But if you come here to the next tab, you have your compiler. Here you can choose the version of your compiler. I'm using 0.8.7, so you may want to choose the same thing. And there's another option here to auto-compile. I always cut that on so that I don't have to keep compiling. It just auto-compiles for me. The third tab is where you can deploy and run transactions. You can deploy virtual deployments, or you can actually deploy externally to like MetaMask. It's pretty cool. We're going to be doing it virtually for this one. So let's go back to the first tab here, find our project. Here it is. All right. Looks like we're all set to start. Now, the first thing that goes at the top of every Solidity file is this license identifier. So it is commented out. It's SPDX license identifier. MIT means open source. We're just going to put unlicensed because this really isn't open source. Next, we have this pragma statement. And the pragma statement is used to enable certain compiler features or checks, but really it just goes at the top of every Solidity file right under that comment. So you write pragma Solidity, and then the version that you're using. So if I come over to my compiler, I'm using 0.8.7. So I'm going to put this caret 0.8.7 and semicolon. With Solidity, everything gets a semicolon. So as much as it's like JavaScript, it's not optional. You gotta put the semicolon. Next, we type contract, the name of our contract, which is CryptoKids, and then an open and close bracket. And now we're ready to begin. So you'll see this at the beginning of every Solidity file. You have the license identifier, your pragma statement, and then your contract name in brackets where you start your coding. So let's do a little pseudocode. We'll want to define the owner, which is going to be dad. We want to be able to define a kid object. We want to be able to add kid to the contract. We want to deposit funds to the contract, specifically to a kid's account. So the contract is going to have the total money in it, but a certain amount is going to be allotted to each kid. The kid should be able to check if they're able to withdraw. So kid checks if able to withdraw. And then if they are, they can withdraw the money. So these are like the principles that's going to guide our coding. The owner is going to be dad. We want to declare him the owner. We want to be able to define kids, add kids to the contract, deposit funds to the contract specifically to individual kids. And then the kid at any time can check if they're able to withdraw. And then if they are, they can withdraw their money. So as far as learning Solidity, I'm just going to, as we go along building this contract, I'm going to talk about the different data types and things that you're already familiar with and how it works in Solidity. So we're going to start out with basic data types. And we're going to define dad as the owner. There are 4 basic data types you need to know with Solidity. There's more, but there's 4 main ones you're going to see. There's uint, which is an integer, non-negative integer. And uint is used most of the time over integer, which includes negative numbers. So there's uint. There's bool, which is true or false. You should know that. There's string, which you should know that. And then there's a thing called address. And all addresses can be sent ether. So for uint, I can say uint amount of money. Bool, I can say is total, true or false, right? For string, you know what a string is, hello. And then for address, there's going to be like a wallet address. So if you go to MetaMask, click on your wallet address, that's what that is. If something is the type of address, you can send it ether. So we're gonna see these data types as we work through this, but I just wanted to point those out. Those are the big 4. So let's go ahead and define dad. It's going to be of type address, owner. He's going to be the owner of the contract. And then, like many other languages, they have this thing called constructors. So if you've used C# or Java or even JavaScript, actually probably most languages have it, Python. And what happens is when an object is instantiated, it gets these values assigned to it. Well, with this contract, when it's deployed, it's only deployed once. So this constructor is only called one time when it's deployed. So that's where we're going to say, hey, whoever deploys this is the owner. So to create a constructor, it's pretty easy. Constructor, and we're going to say owner equals, and there's this message.sender. Now, what is message.sender? Well, message is this global variable that's available to your contract. Here are some examples. Message.sender is the address of sender. Message.value is the amount provided to the contract in way. So if I send some money to the contract, I can access that amount with message.value. Message.data, and then like message.gas, the remaining gas. It's a global variable. And you'll see this a whole lot. You'll see message.sender as the address of the person transacting with that contract. So when dad deploys this contract, it's going to call this constructor. It's going to assign him his wallet address as the owner. That's all that is. Let's look at a few more data types. So think about arrays. Arrays are really easy in Solidity. You can just say uint 5 names. And there you've declared an array of names that can only be 5. It's a fixed length of 5. If you want to declare dynamic, where you can add to it, you can say uint, leave this empty, and names. And then I can do like names.push Travis. I can do something like that. I can do names 0 and change my name to Phil. Then if I want to delete it, I can say delete names Phil, and that'll delete the name from that array. Just basic arrays. You should be familiar with that. It's really easy in Solidity. So that's arrays. What about dictionaries? Well, in Solidity, they're called mappings, and they look like this. So you say mapping string value. So string is the key, uint is the value. This mapping is called kids, and it's public. What is this public? Well, you know, with a lot of languages, you have public and private. With Solidity, you have public, which is visible externally and internally. Then you have private. You probably already know this. You have private. It's only visible to this current contract if it's private. But there's also external and internal. So external means it's only visible externally from a call outside of the contract. And then internal means it's only visible to the current contract and those calling it. Contracts can call other contracts. So this one is declared public. It's available inside and outside of the contract. That's all that means. So I just wanted to go over those two because those are pretty common. There's one other thing we're about to use called a struct or a structure. You'll see this in other languages like Golang. A struct is basically a collection of variables under a single name. It's like an object in JavaScript. So what we want to do is we want to define a kid object because we want to be able to add kids and we want to be able to interact with the kids on this contract. So we need to define what a kid is. So we can just do struct kid, and then you do an open and close bracket. And then you define the different properties of the kid. So we can say address, wallet address, because we want to get the wallet address of the kid. We want first name, so string first name, string last name. And then we want a release time, like what is the time that this money is going to be able to be released to the kids? So uint release time. So we'll define that. So we'll say, hey, they turn 18 at this date, and we'll set that as the release time. And you may be wondering, why not date time instead of uint? Well, all time in Solidity is considered uint because it's based on Unix timestamps. So it's going to be a uint. Next, what's the amount? So if we create a kid, we may want to add some money right when we create them. So uint amount. And then finally, can the kid withdraw or not? So bool can withdraw. If that's yes, then they can take the money out. If it's false, then no, you can't withdraw. And that's our kid structure. So we can say basically kid.first name. We can access the first name, kid.release time, just like that. And since we're adding multiple kids, we want to create an array to add those kids to. So let's do kid. So this is an array of type kid. We're going to make it public and call it kids. So this may look weird right here, but that all it's saying is it's an array of type kid. It's public, and we're going to call it kids. So I can do kids.push, create one of these kid structures, and add it to it. So now let's talk about functions. So functions are pretty easy also. It's a lot like JavaScript. So if you put like function, let's call it increment. Like we're going to increment a number by 1. That number, we're going to pass in a number. It's of type uint. And we'll just call it X. And then if it's returning anything, you have to put returns, and then in parentheses, what it's going to return. So it's going to return another uint. And then we can do X equals X plus 1, or I think you can just do X plus plus. And then return X. And that should increment by 1. That function looks just like JavaScript outside of this returns. And then if you want to call it, you just do increment 10, and that should return 11. So let's write a function then called add kid, so we can add a kid to this array. So function add kid. Then we're going to add in all of our values here. So address. Actually, I'll just take this, and I'll just paste it in there and just fix it up here. Remove all of the semicolons, put commas there. What we're doing is we're just passing these in as parameters. Put a comma there, comma there. In this function, we're going to make it public. Put our brackets, and we can simply say kids.push. What do we want to push? Well, we want to push a kid. And I just misspelled address. And then our kid parameters. So let's fill this in. So we have our parameters here. Let's add in wallet address, first name, last name, release time, amount, and can withdraw, of course, is going to be false. When we add a kid, they won't be able to withdraw right away. Put a semicolon there and save it. So look here, Remix is yelling at us. So it's saying data location must be memory or call data for parameter and function. So it's mad about first name and last name, which are both strings. So what we need to do to fix this, well, let me talk about this. If you go up to the top, this address owner, anything declared like this is what they call storage. It persists on the contract. So owner, it persists on the contract. That data will stay on the contract. Anything in functions is considered memory. And for strings, we need to put that as memory. So first name and last names. So this memory for function parameters are stored inside the functions, and it lives only while the function's running. And we only need to do that for string. And I have another warning here. It says unused function parameter, which is can withdraw. It's because I put a false down here. I thought I could just put that and have a default, but let's switch that to can withdraw, and I think that'll fix it. And save that. Wonderful. So we have our kid, we have an array to put our kids, and we have a function to add the kid. So let's test this out by deploying it virtually and seeing if it works so far. So if you go to your second tab, I have it on auto compile. So I should be good there. If not, just click compile cryptokids.sol and it'll compile it for you. And then go to the next tab, change your environment to JavaScript VM. Either one of these is fine. I'll just pick the first one. The account, I'm going to make the owner account just the first one here. It has 100 Ether in it. Open this up. And all I have to do is just come here to deploy and click deploy. I'm going to deploy my contract. So you'll notice here that there's an orange button and a blue button, and they correspond to our functions over here. So we have add kid, which corresponds to this function, and then kids, which is a getter, which corresponds to this. We made it public, which actually allows us a getter method without actually creating one. So if we click kids, let's choose kids and remember kids is an array. So let's choose 0, which is the first index. There should be nothing. So let's try to add a kid. So let's go to this wallet address. Let's pick the second wallet address. Remember, we're the owner. We deployed it with this wallet address. Pick the second one, and let's try to do something here. So let's add the first parameter, which is a wallet address. Second is the first name. I'm going to say Jane. Last name, I'm going to put Doe. Release time, let's look up our Unix calculator here. Here's a Unix timestamp converter. So epochconverter.com is what I always use. Just going to choose something 5 minutes out. And human time to timestamp. I'm going to choose this timestamp. I'm going to paste that in. That's going to be our release time. The amount, I'm going to make 0. I don't want to send any money. I just want to add the kid. And can withdraw, I'm going to put false. And we should be able to click add kid and add a kid to our array. So add kid, you'll see here that we got a green check. You can open it up to get more details. It'll tell you about the gas, the decoded input and output. We don't have an output. But anyway, now you should be able to come to kids, hit 0, because remember kids is an array. 0 will give you the first index, and we should be able to see the kid we just added. So click kids, and there it is. We have the values for that kid. So we have the wallet address, Jane Doe, release time, 0 and false. So far, our contract is working. Awesome. Let me move this down, make some room. Now let's move these around, this pseudocode I had. So we defined a kid. I'm going to put that right above the struct. Next, add a kid to the contract. Let's put that right above this function. And then next, deposit funds to the contract, specifically to a kid's account. So to deposit funds to a smart contract is really, really easy. It just involves this. Look, function deposit address, wallet address. That's going to be our parameter. We're going to pass in a wallet address to deposit to. And then payable. Remember, we talked about that payable word because we're sending Ether. We got to use payable. We're going to make this public because we want to be able to access it outside of the contract to be able to deposit funds, and open and close brackets. And to be honest, that's all we need to deposit funds. We don't have to put anything in these brackets. That in itself, this deposit function, will do that for us in the fact that it's payable. But that's going to deposit the funds to the smart contract. That's going to be our total amount. But we want that amount of funds specifically to go to certain kids. So we are going to do something in here. So if I come over here and I delete my deployed contract and go back to my owner, I deploy a new one, switch to my first kid, copy that, and create a kid again. So you see we have this deposit button, which is red. And if I add a kid, let me add the wallet address, Jane Doe. Get that timestamp again, 0 and false. If I can't spell false. False. If I add a kid, again, I can put a 0 to see my first kid, and there they are. Now I can deposit money. Let's say I want to deposit 1 Ether to the contract. I can come up here, change way to Ether. And by the way is actually 10 to the negative 18th Ether. So if you ever see 1, 0, 0, 0, 0, 0, 0, 0, 0, that's way probably. Then there's gigaway, which is 10 to the negative 9, which is a little smaller. And then there's Ether, which is easier. 1 Ether, 2 Ether, 3 Ether. But there are smaller fractional amounts called way. So anyway, you can choose way. You can choose gigaway, I think. I don't know what a finny is. But anyway, I'm going to choose Ether. So I just change that to 1, click deposit. And that didn't work because we need to enter a wallet address. So let me copy that kid, paste in their wallet address, click deposit, and there we go. We just added, see this 1, 0, 0, 0, 0, that's way. So that's harder to read than just 1 Ether. Anyway, you can read up on that some other time. But how do we know we have that in our account? We need to create a function that gets our balance so that we can actually test to see that that worked. So let's create another one right above this. We'll do function, we'll call it balance of a public. It returns a uint. Remember, when we return something, we have to specify what that is. So it returns a uint, and we'll just say return address this dot balance. Now you may be like, what in the world is that? This is just convention. We're returning address.balance, and we put this to specify that this contract, whatever this contract is, the balance of that. Again, this looks wonky, but you'll see it everywhere. And we have a warning here. We hover over that. It says expected, but got return. Let's see. Oh, yeah. We're supposed to put returns with an S. Okay, let's save that. We have another warning that says function state mutability can be restricted to view. So this is really important. Whenever you run these functions and they interact with the contract, it costs gas. It costs you transaction fees. Now, there are 2 other types of functions that won't cost you gas, and you need to use those to optimize your contract when you can. The first one, and the one that we're going to change it to, is view. And what this view means is that it can't change the state of these storage variables. And that's important because it can only execute locally, not on the blockchain. So this protects the function from executing anything on the blockchain, thus costing no gas. It just interacts with the contract locally, not on the blockchain. And the other one is called pure. And pure is actually more strict than view and doesn't even allow the reading of state variables. The good thing about Solidity is it'll warn you. It'll say, hey, this one you can use view. You should use view to optimize. So it'll tell you, but just knowing those 2. So view, you'll see a lot more than pure, I think. So we'll change this to view and our error goes away. So let me copy this add kid so I won't have to do that again. Let me save this, and then I'm going to delete this contract and deploy it again. Go back to my owner, click deploy. I'm going to add a kid, add kid, make sure that worked. There it is, my kid is added. Now I can deposit to a kid, so I'm going to pick the next address, 1 Ether. And that kid's wallet address, I'm going to put here. And deposit. That deposit worked. Now I should be able to click balance of and get back the total amount on the contract. So balance of, and there you have one, however many zeros of way, which is 1 Ether. So everything's working. Everything's looking good. So as we were saying earlier, we want to be able to deposit funds to the contract, which we did. But we want specifically for it to go to certain kids' accounts. So I'm going to open this up, and I'm going to create a function that doesn't exist yet called add to kids balance. I'm going to pass in that wallet address. And I'm going to create the function right below it. So function add to kids balance, address, wallet address. And I can make this private. And what we're going to do here is now we're going to look at loops. Now what's neat about loops in Solidity is it's just like JavaScript. So what I want to do is I want to loop through the kids and figure out whose wallet address this is, and then add that money to the amount variable on that kid. So like I was saying, just like JavaScript, all you got to do is do a for loop. Uint I equals 0. I is less than kids.length. And then I plus plus. The only thing different, of course, is the statically typed uint. And then I'm going to do an if statement. So if kids I, whatever index we're at, dot wallet address equals wallet address, which is the wallet address we're passing in. So as we loop through the kids, if that wallet address of that index kid equals the wallet address, then we're going to add the money. Kids I dot amount plus equal message dot value. Here we go again. There's a global variable. Message dot value is the amount of money we're sending to the contract, the value that's being sent in this message. Now we should be able to save it. And that amount of money should now go to the kid. So the total money is going to go to the contract, but you should be able to see how much is allotted to each kid. And just a note about loops, there's a lot of stuff written up about not using loops in smart contracts because it can potentially use a lot of gas. It can charge you a lot of transaction fees because of the processing that it does. Well, we only have like 5 to 10 kids. If you had like hundreds and hundreds and hundreds of things you're looping through, then yeah, maybe you want to optimize it in some other way. But for this small amount, I don't see the problem. And anyway, we got to use loops, right? Because we have to demonstrate all these data types. So let's try this out. Let's deploy the contract again. Make sure I go back to my first address, deploy it. And I'm going to add a kid, grab my second address, and I should have actually, I think I have this in my clipboard. Yeah, there we go. So I'm going to add a kid, and let's add another one. Let's pick this third address and change the wallet address. Instead of Jane Doe, let's call it Jim. Everything else should be the same. Timestamp doesn't matter at this point. We're not adding any money. We'll leave this false. We'll add this kid. So now we should have a kid at index 0, which is Jane, and a kid at index 1, which is Jim. Neither one of them have any amount of money. So let's send Jim some money. Let's put his address there. Let's send him 2 Ether. So deposit. And if we do balance of, we should see there's 2 Ether in the contract. And if we check him out under kids now, he should have 2 Ether. Great. Now let's send Jane, which is going to be the first address here. Let's deposit Jane like 5 Ether. Deposit, and now we should have 2 plus 5 is 7. We should have 7 Ether in the account. There it is, we have 7. But if we go to Jane now, she should only have 5. There it is. Amount is 5 Ether. So we're getting the total amount of the contract, and we're breaking it up per kid. And you'll see up here these differing amounts in the wallets. As we're sending from these wallets, it's being deducted from the wallet. What's pretty neat, it's pretty neat that Remix gives you 100 Ether to play with. So anyway, if I'm if I'm the owner here at 96.9 and I send 6 Ether to the first kid, so I'm going to choose the first kid, go back to my owner. If I send 6 Ether that way, I should only have then like 90 Ether left. So if I click deposit, yeah, I have 90 Ether because I just sent 6 to the contract. So that's pretty neat that we have all this Ether to play with. All right, next up, we need to create a function to see if the kids are able to withdraw. So if that kid comes to the smart contract and they say, hey, I want my money, they can click this and see whether they're able to withdraw or not. So let's do function available to withdraw, address, wallet address. Let's make it public, and it returns a bool because we want it to say true or false. And what we're going to do also here is we're going to do a loop to see which kid is associated with this wallet address. But I'm just going to create a function outside of this to find the index. It'll make it easier because we're going to need it again in the next function also. So right above this, I'm going to say function get index. This is just going to be a function that gets the index of the kid we want, whose wallet address matches. And we'll do address, wallet address. We'll do it as a view. Remember, we talked about this. This isn't interacting with the blockchain at all. This is just internally in our contract. So it'll save us some money. View, we'll make it private and returns a uint. So it's going to return the index of the kid. We'll do our for loop. Uint I equals 0. I is less than kids.length. Then I plus plus, just a basic for loop. And we'll just say if kids I, put this in parentheses, dot wallet address equals wallet address, return I. So we're just going to return the index. Now, it's going to give us an error because if nothing matches this, we're not returning a uint. That's something that's cool about Solidity. It's very particular about this. So if nothing ever matches here, we'll never return anything, but we're saying up here it must return a uint. So we need to do something here like return -1. So if it does match one of the kids, we're going to return the index. Otherwise, we're going to return a -1. But we have a problem. If we hover over this, it says, well, the first problem is we don't need a comma here. We need a semicolon. But it's going to yell at us down here with this -1. The reason why we can't use a -1 is because we're returning a uint. A uint is positive. An int also includes a negative. So you think, well, maybe we can just do int. We can return an int. Well, we can't do that because this is a uint. And then, of course, we can put an int right here, and that won't fix it because this for loop needs to be a uint. So there's multiple ways we could fix it. I don't want to really stray from the uint and start using ints, because then if we do that, this number, every time we have a loop down here, or anytime we have a loop in another function like this one, it's going to be messed up because this is going to be an int, not a uint. So we're going to have to do all this casting and conversions and stuff. So what I'm going to do, just for sake of ease, you can do something different if you want. I'm just going to put return 999. I mean, we're never going to have more than like 20 kids in here, but I'll just say return 999. Not a good solution, but a quick fix for our video here and keeps us moving ahead. So we're going to call this get index. We're going to pass in a wallet address. It's going to loop through the kids, find the kid that matches that wallet address, and return their index. If it doesn't find a kid, it's going to return 999. So now in this available to withdraw function, we can simply say uint I equals get index wallet address. And that's going to get the index of the kid we want. Makes it much easier than continuing to use for loops and all of these functions. And we could probably use it up here also, but I'm just going to leave that as it is. And then what we want to do now is we want to check if the current time is greater than the release time. If it is, then available to withdraw is true, right? If the release time is at 5 o'clock and our current time is 5:03, then hey, we can take the money. So to do that, it used to be in older Solidity versions, you use this now. You can just put now and it'll tell you the current time. Now we have to use this if block.timestamp. And I know a lot of things are written up about how block timestamp is not good because the miner can manipulate the time, but they also say that that only is a problem if it's a time within 15 minutes. So if it's a time within the next 15 minutes, before or after 15 minutes, then you may not want to use this. There's some alternatives out there. But because the kid's like 9 years old, they got 9 years left. So it's not 15 minutes, it's like we're talking years. So the manipulation can't be a problem here. So we're going to leave it. Block.timestamp is greater than kids index release time. If so, then that kid at that index can withdraw equals what? True. And then return true because we got to return a bool. So what that's doing is if the current time is past the release time, then we're going to flip that can withdraw for that kid to true, and we're going to return true. Else return false. And we have a warning here. Let's see what's going on. Oh, we forgot our period here. So kids I dot release time. So this function is going to check if we're able to withdraw or not. And while we're at it, let's go ahead and create our withdraw function. So to withdraw money, so let's say that they're able to withdraw. That's true. Now we want them to be able to click something and send the money to their wallet. Let's create that function. Let's put function, withdraw, and then here, address, wallet address of type payable. Remember, when they click this withdraw button, it's going to send money to their wallet. So we need to make this payable, and we need it to be public so they can initiate that outside of the contract. And we'll do this, we'll get our index again. Uint I equals get index wallet address. This gets the kid we're looking for. And to withdraw, we put kids I, that particular kid, wallet address. And anytime you use an address, you can use a method called transfer. And you don't want to transfer the whole amount in the contract. You just want to transfer that kid's amount. So here we'll put kids I dot amount. And we have a warning again. Send and transfer are only available for objects of type address payable, not address. So what we have here is we made the function payable, but this actual wallet address also needs to be payable. That should clear up our error, and it does not. And the reason why is because kids.wallet address, so the wallet address property of kids also needs to be payable, which brings us back to what we were talking about earlier. Up here, where you add a kid, you need to make this wallet address payable. I think that should clear it up, and it doesn't. Maybe the address on the kid actually payable. Yeah, that was it. So I don't think we need to set it here. Yeah, we do. So we need to set payable for the actual struct withdraw wallet address, and also the payable at the add kid. When we add the kid, we need to make sure that wallet address is payable also, because we're referencing it down here. We're referencing that property. And what's neat about Remix is they'll remind you of that. It catches errors really nice, and it's easy to debug. So I think that function is good. Let's save this and test it out. So I'm going to delete, actually, let me save Jimdo and close out that contract. Let me go back to my owner deploy the contract. And what I want to do is I want to add a kid, but I want to make sure that the time is like 3 or 4 minutes from now, so we can see that works. So currently it is 10:38 p.m. Let me refresh this page. So whatever this is, 2:38. I'm going to change this to 41, so that'll give us 2 minutes. Grab this timestamp, and so it shouldn't work until 10:41. So I'm going to put that there. I'm going to add the kid. So I should be able to go down here, click on kids. Yep, added the kid. I'm going to deposit. I'm going to deposit a couple Ether. How about 4 Ether? Click deposit, check the kid again. Yes, they have 4 Ether. Balance of the contract is 4 Ether. And then able to withdraw. So let me take this kid's address and pick available to withdraw. And if I open this up now, if I come over here to this drop down, open it up, it should say false as an output. Yeah, so decoded output is false. So that's good. It's not able to withdraw because it's not 10:41, it's 10:39. If I go to withdraw, it shouldn't do anything either. Actually, we need to set some requirements there, but if I click withdraw, I still should have my money. Actually, no, I don't want to do that because we don't have any checks there. So this would actually work. So we need to go in and talk about that next, which I had planned. So we just need to wait this out. So I'm going to wait 1 minute and then we'll check this again. So available to withdraw, make sure it's still false. Yep, the output is false. And if we check the kid, their can withdraw is false. So once 10:41 hits, we should be able to withdraw. This should show up true, and it should flip this can withdraw to true for the kid. So I'll come back when 10:41 hits. Okay, now it's 10:41. We should see available to withdraw showing as true, and can withdraw showing as true for that kid. So let's click it again, available to withdraw, open this up. And we'll see bool is true. So that should have flipped can withdraw to true. Let's check the kid. There it is, can withdraw to true. So we know that our available to withdraw function works. Now we need to set a few checks. And this is really important in Solidity. It's really easy, but it's really important. So there's a couple things I want to check. First, we don't want other kids being able to withdraw other kids' money. You should only be able to withdraw your own money. So what we do in Solidity is we have these require statements. So I'll say require message.sender. Remember whoever's interacting with the contract. So if somebody clicks withdraw, the message.sender is going to be their wallet address. That's a global variable. Equals kids. Actually, this needs to be under that one because we're about to use the index. Kids index dot wallet address. So this requires that the sender be that kid. So that wallet address matches the person interacting with it. And what happens with these require statements is you have a second option of some kind of text you want to put out there as a warning. So I would say you must be the kid to withdraw. So if some other kid tries to withdraw this now, they're going to get this error, and it's going to say you must be the kid to withdraw. Now, what's cool about require is it actually reverts the transaction so that you don't spend the gas. You don't waste the gas. Now, another check, and probably the main check, is that they can't withdraw until this can withdraw value is true. So we can put require kids at that index can withdraw equals true. So again, we're getting the index of the kid up here. So checking that kid, their can withdraw value. If it's true, then they can withdraw. If not, then we're going to put a warning saying you are not able to withdraw at this time. Awesome. So what's cool about smart contracts is they're immutable. Like once I put this out there and it has these requirements, like nobody can mess with it. It's immutable. You can't change this. So let's go up to the one above it. We want to put some up here too. So available to withdraw. So here again, it's checking that the current time, if it's greater than the release time, then they're able to withdraw. If not, they're not able to. So let's put a require statement here if the condition is false. So if they can't withdraw yet, we're going to revert it and say you're not able to withdraw at this time. So require, and it's going to be the same here. Require that the block timestamp is greater than the release time. If not, you cannot withdraw yet. That's all. We'll leave it at that. Now let's add one up here to adding kids. We want the owner only the owner can add kids. We don't want anybody just coming on here adding kids to the smart contract. Like when you get the front end web interface, we don't want people to just jump on there and start adding their kids. Only the owner of the smart contract can add kids. And we're going to do this one a little different, just so I can show you how a lot of people do these things in Solidity. So we could put a require here. We could say require message.sender equals owner. And then only the owner can add kids. We could say that. That's fine. But what if you also, you wanted the sender equals owner on like 5 other functions? You don't want to repeat this over and over throughout every function. So one convention in Solidity is something called a modifier. And this is really powerful. If I do modifier, and let's call it only owner. And what you can do is you can put the require statement here in the modifier. And right after that, you're going to put this underscore semicolon. And what that means is the rest of the function. So what you're doing is you're taking, move this out. You're taking the rest of this function and putting it here where this underscore is, like right there. But what you can do is, because this is here, you can use it on any function. So instead of putting the require there, I'm going to come over here to the right past this public and just put only owner. So after your parameters, you're going to have public, it's a public function, and then you can just declare this modifier, only owner. And what that does is when anybody calls this function, it jumps up here and it says require this, and here's going to be the rest of the function. I can come down here and I can, if I wanted it here, only owner. If I wanted it here, only. So it's really powerful. You can use this over and over. So a lot of people do it that way instead of putting requires all over the place. And one of the last things I want to talk about before we test that this all works is something called events. Events are really important in Solidity. What you can do is when something happens, like a function is called or at some point in a function, you want to emit an event, you can create an event and you can emit that event so that on your front end, your React project or whatever you're using on the front end can receive that event and do something with it. So let me show you by example here. So right under this owner, I'm going to put event, and let's call it kid funding received. And I think by convention, people put log in front of it. So log kid funding received. And this is an event that's going to fire when a kid receives money. So if I was on the front end and I wanted to put a big pop-up or something fancy on the front end when the funding was received, I can receive the event this way. And as the parameters, I'm going to put address, put ADDR for address, uint amount, uint contract balance. So what I'm doing is I'm creating an event called log kid funding received, and I'm going to pass that event the address of the person depositing funds, the amount that they deposited, and then the full contract balance, and be able to do whatever I want with that on the front end. So the event is defined here. Now we have to emit it. So down here, add to kid's balance. Right after this, so down here when this amount is updated with this new value, I'm going to emit the event. So we put emit, log kid funding received, and wallet address. So we have the wallet address of the, actually this is the wallet address of the kid. Sorry, I think before I said the wallet address of the person depositing, but this is the wallet address of the kid. Message.value, so the amount. And then we have a function right up here called balance of that gets us the balance of the contract. balance of, and semicolon. So on the front end, we got the wallet address of the kid. We can do something to that kid's profile or something neat like that. But events are really powerful and something you want to use in Solidity. So that's it. That's all I want to do. Now we just need to test this out and see that it all works. So come over here and delete your old contract and choose your owner. Anybody can be owner, but I always choose the first one, and deploy it. And we're going to add 2 kids so that we can make sure that each kid is only getting their amount, not the full amount of the smart contract. So, okay, we have Jim Doe. Second address up there just so I can keep track. And we're going to go to this time converter. It's currently 11:02. I'm going to change this to 6 and 0 seconds. So 11:06, grab the timestamp and use that. And I got to be my owner to add a kid, remember. If I try to add a kid with someone else, I'm going to get an error saying only the owner can add kids. Good, that works. So I'm going to add that kid. Now I'm going to go up here and find another kid. Let's see. Yep, grab this third kid, or the third person on the list, which is the second kid. I'm going to add that address, change Jim to Jane, and add her, same time. Only the owner can add kids again. Go back to the owner to be able to add a kid. So now I should have Jim and Jane. Great. So I'm going to send Jane some money, put her wallet address in deposit, and send her 4 Ether. So deposit. And if I look her up, she now has 4 Ether. The contract has 4 Ether. If I grab Jim's address, so deposit 2 Ether. If I look him up, Jane has 4. Jim has 2, and the total is 6. Wonderful. So that's working fine. Let's see if Jane is able to withdraw. And it says you cannot withdraw yet. So right here, it hit our require block because we're not able to. Now let's see if she can, and that's checking if she's available, if the money is available to withdraw. And that's checking if the money's available to withdraw. Let's see if she can actually withdraw the money. So we get an error that says you must be the kid to withdraw. So let's actually switch to her. See if we can withdraw. And it says you are not able to withdraw at this time. Great. So the can withdraw has not been flipped to true. So both of these requires worked. This require worked. And when 11:06 hits, we should be able to withdraw. We should be able to check available to withdraw. And it should flip it to true and return a true. And at that point, we can actually withdraw the funds, and only 4 Ether should go out to her wallet, and the 2 stay in there for Jim. Hope that makes sense. So we'll check that out at 11:06. All right, it's 11:06 again. If I check my balance of, I have 6 Ether. Jim has 2. Jane has 4. So what we're going to do is I'm now Jane, and I'm going to withdraw my 4 Ether. Now I'm going to first try to withdraw. It shouldn't let me because that can withdraw value is still false. So I'm going to check that, and it says you are not able to withdraw at this time. So I'm going to go to available to withdraw and see. So now it should flip this to true and return a true because it's after the allotted time we set. Let's click available to withdraw, and that worked, I think. Let's open this up, and it says bool true. Awesome. And if I click on kids, we'll see that Jane can withdraw is set to true. So now all that's left is to actually withdraw the funds. Again, we have 6 Ether. When I click withdraw, it should send 4 out to Jane, which if we look at our address up here, DB, which is the third one, she should end up with 104 Ether after this because that's going to be sent to her wallet. So let's click withdraw. Looks like it worked. Jane now has 104 Ether. And if we check balance of, it should only be 2 left. There it is, 2 Ether. And if we check out Jim, he should have those 2. There it is, 2. Wonderful. So what we did was we waited to the allotted time. We checked if Jane is available to withdraw. She was, and it set it up. It set that can withdraw to true so that she was available to withdraw. And then we clicked withdraw and it sent only her money to her wallet. So there you have it, a working contract, a nice Solidity tutorial. Hopefully you learned a lot from it and would be able now to check the documentation and build out your own smart contracts. Now I have one recommendation. If you go to a site called Learn X and Y and just type Solidity, there's a site called Learn X and Y, and basically for each language, it just gives you a ton of examples. It's kind of like the site for the developer. Like you don't need to learn what a variable is, what a loop is, all of that. It just gives you a bunch of examples of that language. So right here, I think it gives you a sample contract first. Yeah, so this is first a simple bank contract, gives you that example. And then here it goes through the basics of Solidity, data types, and all this good stuff. So if you wanted to create a Solidity contract, you can take what I've taught you here, and then you can say, oh yeah, how do we do loops again? Oh yeah. And you can say, oh, how do we write functions again? Oh, here's functions. What was pure and what was a view function and all of that? All of it's here. Everything you want to know is in this list. It's kind of a cheat sheet for building your own smart contracts. Now you've created your smart contract, which is the brain of this whole thing, but just for kicks, I wanted to show you what a potential front end would look like, just to give you a bigger picture of this whole thing. Now this is just a UI, it doesn't do anything, but essentially you can add a kid. So there's 5 kids here. So if the grandparent has another grandkid added, they can come here, add a new address, first name, last name, and release time, and they can submit it and another kid will be added. So here's Joey Lawrence, invested 3.6 ETH. So over time, the grandparent has invested 3.6 ETH on this child, and then they've set the release date for May 1st, 2042. So let's say, hey, the kid will be 18 then, or 21 or whatever. There would also be a button here that says can withdraw, and then another button that says withdraw. Maybe you don't even want to show those until the time comes. Whatever. And then if the grandparent wants to deposit funds for a kid, they can come here and punch in the kid's wallet address and then the Ether amount. So I'm going to send Joey Lawrence to Ether. I would put his address here, joey.eth, and then send him to, hit submit, and he would have 5.6 ETH. So again, I'm just giving you this to give you a bigger picture of what's going on. Hope that was helpful. If for some reason you want to see this hooked up to the smart contract and functional, and I get enough requests for it, then I'll do that in another video and we'll walk through making this UI functional with our smart contract. So great job today. See you in the next video.